Hey, I just wanted to give a quick update on the Raspberry Jam project. Raspberry Jam it's basically an SD card image for Raspberry Pi that is tailored through running Jacktrip, which is software that allows you to collaborate in real time with other musicians. This is a project we started during the pandemic to help people play music together. And we now have an SD card image for the Pi that you can run that's already got everything kind of already set up. So I'm going to go quickly through what we've done and how it works. This is a GitHub page, the wiki. This is if you go to the quick start guide on the wiki, it talks specifically about what you need on how to set it up. So I'm going to show you quickly how that works and then show you how to actually use it. So this page goes over what you need. You do need a sound card. Right now we support two, the FE Pi and audio injector. We can add others. That's just what we have for right now. We've been using a Pi 4. I believe we've also tested on Pi 3. But anyway, if you go through this quick start guide, it gives you some of the details on what the hardware you need. But once you got that set up, you can go to the releases page, download the SD card image, put that onto your Pi, hardwire it to your Ethernet, and boot it up. And when you do that, you can go to a URL here, raspberryjam.herokuapp.com, and it should show up your Pi there. So you don't even need to know the IP address. You can just find it through this little site. You click on that, and then you can configure your Raspberry Pi. So you select which of the two sound cards you're using, and you put in the token for the Blink app. So we're using Blink as a mobile app to control this. We plan to develop other UIs. You don't have to use Blink. You can basically run Jacktrip from a command line or whatever. It's already on there, but this is the quick and easy way to do is to use Blink. The quick start guide goes over how you set that up. But you paste your Blink token in here, select your sound card, hit save, and the Pi will reboot. And once you've done that, let me just share my screen here. This is the Blink app. So we've got it set up now for basically for 4 connections, for a 4-piece ensemble, I guess. Yourself, and then there's three peers that you would connect to through this app. So that's you can see these 3 rows here at the top. The first one's named Test, but it's user 1, user 2. Those are the connections. Down at the bottom, you have some. At the very bottom, you have some settings for the sound card. So there's an input select, either mic or line input, and for when you have a mic, there's a mic boost. So these are kind of sound card specific, but at least the 2 cards we're using both have an input select and some kind of mic gain adjustment. So those can be made through the app. There's levels, input and output levels. Those control levels in also mixer for the sound card. So the output level is basically the overall volume. Input level is the capture level. On certain cards, the input level only affects the line in, not the mic in. But and then there is local monitor gain. So that's how much of yourself you hear. So you can also control the gain of your peers once you've established a connection with these gain sliders. And that local monitor gain is how much of yourself you're hearing in the overall mix. So you can control the mix once you're connected. In order to set up a connection, you hit the edit button. And for each connection, you would have a server and a client. In this case, I'm going to be the client. This Raspberry Pi will be the client, so you can enter in the name. And the IP address is already populated there, but you type that with a colon, and after the colon is a port offset. So each connection is a unique port. This is the first one, so it's going to be 0. So it's the IP address :0. It would be 1, 2, 3, whatever offset you wanted to use for the other ones. It just needs to match your peer. That you need to use the same offset for corresponding connections. So we've got that set up. And then, so this guy's ready to go. if we go to the other Pi, so normally this would be what your peer would see, but I've got 2 Pis set up here on the same LAN. And also one note is that little circuit board picture at the top. There's a little red 1 on there if that's disconnected. So the fact that it's not there means it is connected. So the Pi is talking to the Blink cloud and connected to the app, and I'm able to control it. So this is going to be a server. The connection's already set up. So I can go ahead and hit start on the second Pi here. So it's waiting for a connection from the other Pi. If we go back to the first Pi and start the connection on that, we actually got an error, and that's because we had a different sample rate. So they both need to be the same sample rate. The second Pi set it at 48, so we'll change that to 48. And I saw that error actually on I have a HDMI cable connected to the Pi. You do get more debug information that way. If you're having issues, you can do that, plugging the screen to the Pi, and it spits out a bunch of information on what's going on. So it showed me an error there that the sample rates didn't match. So now that I've got 48 here, I'll need to restart the connection on the second Pi and go back to the first. Hit start, and we've got a connection now. So we're connected. We'd be able to hear each other now through this connection. As one of the other adjustments here is this latency. There you can increment and decrement the latency. That's basically the Q switch in Jack, lowercase q, in Jacktrip, for those that are familiar with using Jacktrip. But basically you can adjust. If you've got a lot of artifacts, you bump that number up and it will sacrifice some latency, but it should clear things up. So you can kind of, and it automatically reconnects when you change it. So I can change that. See, I just bumped it up to 5 from 4, and it restarted everything and reconnected with that. One of the other features is we can actually test what the latency is within this app. So if the client goes into test mode first. So what that does is establish a loop back to the server, and then the server, if we go to the second Pi, that's a server, and put that in test mode, it actually sends a signal and looks for it to come back. So you can see the latency is 10 milliseconds. That's the time this took the signal to get from this one Pi to the other. I ran it again, it was 4.6 milliseconds. So these are on the same LAN, that's why it's so low. It's not actually on across the internet, but it's a little useful way to see what the latency is. And then you can make adjustments either to the sample rate or to the latency setting in order to try to get the latency as low as possible while still being usable. So, it increases artifacts as you get faster, but it's just a matter of what your tolerance is for that versus a tolerance of a latency from hearing your other peers. So that's basically how you establish a connection. Now that it's established, I can adjust the gain, and I can adjust the gain of myself, and we're good to go to perform together. You just repeat that for the other 2 slots. You get the IP address of your other peers and go through the same process to connect up to 2 more people. We may bump that up. It's not necessarily limited. We're not running into any issues with throughput on the Pi, so I don't know how many connections it potentially could support, but we could experiment with that. But for what we wanted to start with as an MVP, 4 seemed like a good number. You can also save this. So now that I've typed all this in, got everything set up, I can save the session. If I click the Save Session button and enter a name, that saved the session, and so you see in the load session now it populated the test session. So I could select that again, and it would keep all the settings I had. So if you've got a particular group of people you're playing with, you don't have to go through and edit every connection every time. So yeah, that's the gist of what we've got right now. Like I mentioned, we're looking at doing other UIs, so that's what we'd like to get more people using this and get some help and some input on where we should go from here. We're working on separating the back end more from the UI, so you could do MIDI control. We've already actually got some of that. I've got I can adjust these faders. Of course, you can't see it, but I'm using a MIDI controller as opposed to my mobile device. So we want to expose more of this to MIDI, so you wouldn't necessarily need a mobile device. You could have a hardware interface, a MIDI interface that had the buttons and sliders to control this, or maybe it's a web-based UI instead of a mobile app using the Blink platform. But that's all possible, and we're working on all that. But we'd like to get some input from folks on what they'd like to see, and try this thing out and see what kind of issues you run into. So anyway, download the image and give it a whirl.